The question was stylistically capitalizing constants. Do you capitalize constants? So you might like shouty constants, right? So disclaimer, all caps. No, absolutely no. The Swift programming guide says that for both constants and variables, so constants declared with let, variables declared with var, are lower camel case, which is they call Pascal case upper camel case. So that's where the first letter is capped, and then every other word is capped. That's in most of the world called Pascal case. Apple calls it upper camel case. This is lower camel case. So if I had like disclaimer 2, right, then I would cap the next word. But yeah, so this is a constant because it's not going to change. Playgrounds are buggy and likely to crash. So that's interesting, right? So that's how I do a constant. Now what's interesting about this is one other bit about the type. So I said it's type safe, it favors constants and that sort of thing. It also has very strong type inference. So I don't need to do this. It knows, and I can inspect it, that that's a string, because what's on the right-hand side is a string. And it's very strong about this. You'll see it as we move forward. Sometimes I'll declare the type. The first time you see a type, I'll probably declare it explicitly. The next time I might do it using inference so that you can see that it works even with really complex types as we move on. But the compiler is very good about this. So just to keep a running total, just in case, we'll do a variable. So this is the number of playground crashes that we've had so far, and we'll set that to 0. Seems reasonable. And note that that has been picked up as a type. Any guesses on what type 0 would be as declared? Yeah, it's an int. So this is as if I had typed int, right, like that. So that's cool. What else could we do? So what's another number type? We could do something with, say, a floating point number, double, which will be the default floating point number in Swift. So my heart rate at this point, as a double, anyone want to hazard? It's probably pretty high. 120, 120.4, I don't know. So that's a double. So that's how we can work with that. What if I wanted just the integer component of that, right? So in some languages, we would typecast. I would throw int in front of the variable name in parentheses. So something like let, no, it's going to vary. So var heart rate as double, or no, as int, sorry, as int. So you might think that in other languages you might do something like this, say int, and then give it heart rate. That's not how it works here, so it's not going to work. That's actually an error, and you can see it off to the left. There's a little red dot. The way this works is I actually create a new double and pass in the heart rate. So the double object has what we'll see is called an initializer. So this is like newing up an object in C#, or other languages where I say some variable equals new something, right? Yes? Yeah.
I got in trouble with this with JavaScript one time.
Yeah.
Where I had it equal to quote, TRUE quote, and all of a sudden it became a Boolean.
Yeah.
Same way with 0, like would it take number of crashes equal 0? Would it maybe confuse that as a Boolean?
Okay, so the question is, would something equals 0 get confused as a Boolean? No.
Or the word true, TRUE.
No. Like in quotes?
Yes.
No. So that would be a string. So Swift, with the type safety angle, Boolean is defined, and I should state, so double, I'm passing in a heart rate to the double into what's called an initializer. You can think of it like a constructor. Why do we have a constructor on something like double? Well, double's a struct, and as we move through the data types, structs and classes are very similar. They both have construction mechanisms, but all of the types, int, double, I believe, string's a class, but like int, double, float, bool, these are all structs in Swift. And because they have specific types evaluated to them, like a Boolean can only accept true and false as keywords, right? So if you pass it a string, it's invalid. True in quotes is not a Boolean, it's a string. 0 is not a Boolean, it's an int. That make sense? Any other questions? You guys can stop me at any time. Huh? I sure do. This is useless. You guys are great. I love you. I love you already. Yeah, so we get the integer value there. Yeah, of course. This guy's dumb. All right, anyways. All right, so where are we at? So we've done ints, we've done this sort of thing. What if you had more than one value that would make sense to package together? Ever wanted that in a language? It's actually super cool. So maybe I wanted to represent the response from a website, perhaps. So I'll say let web response equal. What could I reasonably expect to get back? Well, I might care about the code, the status code, right? So let's say I want the 404 that came back, and I want the description of that came back to say not found, right? So womp womp. I tried to go to the website, and I got a 404, and if I don't know what 404 means, it means not found. So what you can see in the results, by the way, there's a result panel off to the right if you hadn't seen that by now. The result panel gives me those two things in parentheses. The one says .0 and the other one says .1, semantics. But if I do web response .0, it's 404. I can pull that inline, another feature of the playgrounds. It's subscripting, right? So I can actually access the elements of this thing that's called a tuple or tuple, depending on where you're from. I call it tuple, and I can access the individual elements of the tuple this way. Or, if I wanted to be a little more explicit about this, and this is super helpful, I can name the pieces of the tuple. So this is the status code, and this guy is the description, right? Now the .0 still works. It's still completely valid. But I can now do things like .status code off of that tuple and get the 404 back. Where this is super valuable moving forward in the language is when you want to return a structured piece of data without creating a new object for it out of a function, right? So you can pass these guys around, you can return them, they can be parameters, and you'll see they are like the parameter list object when we start talking about functions and closures. This is how parameters are represented. So I have the option to peel off whatever I want out of this guy. So that's neat. That's tuples. What about scenarios where I have a variable or a constant, actually a variable in this case, constant doesn't apply, but I have a variable that might not have a value. Perhaps I go to fetch some content out of, I go to make a request for something, and I want to represent the state of being where this can either have a value or not have a value. Swift calls these optionals. So I can create something like, address, and that will be a string, but it's a string optional. And I can set a default value explicitly and say nil, and nil is the nothing state for objects that are optionals. So I can specify that explicitly. It's also the default value, so you don't have to do that if you want to just initialize one straight up this way. And where this becomes valuable is when we query objects or query strings. Let's take for instance, what can we do? What's a good example of this? I had a good one in my script. Yeah, so let's say we had a string. We'll call this is integer. Let's say we had a string that represents a number. This is not a number. That equals test. And we'll have one that is a number that equals 1, 2, 3, 4. So these are strings, right? So if I try to call toString or toInt on not a number, it's reasonable right, for that to return nothing. It's not an error. I tried to do it, but it's not actually an integer. So the way Swift chooses to do that in this method, and I can inspect that option click, it might be hard to see, but the declaration for toInt says that it returns an int optional, int question mark, which means, hey, if I can cast this to an int, or if this thing can become an int, I'll return the int for you. If it can't, I'm just going to return you nil. And then that's on you. And if I were to call that, obviously, on is a number dot toInt, we get 1, 2, 3, 4 out as an integer, as you can see over here. Does that make sense so far? These ones are obvious. It's really easy to see what's going on with these. A lot of times you're going to be getting data out of methods where you don't know because you're passing something in, a whole bunch of stuff happens, and out pops this optional thing. So that would be really frustrating if we had to do things like we have done in other languages, and we say if not a number equals equals, if it's not equal to nil, right, then in this case, we would have an integer, right? So this would not print. Never gonna happen. Right? And that's cool. That's a lot to write to get to that point, I suppose. And it's not necessarily clear. Like I had to think about it because I used a not equal, right? So I have not a number not equal to nil. Like what is that? I don't necessarily understand what I'm doing anymore. Wouldn't it be cool if there was a syntax when working with this sort of thing that allowed me to just say, hey, if this thing exists, can you assign it, can you assign it temporarily to something or whatever, and let me just work with it. So I can do something called conditional binding. So I can say, and I'm going to do it with I'll do it with not a number. Wait. What is the syntax? It's not helping me. If let number equal to not a number. Else do this. That's a bug. What did I do? No. No. I got the syntax wrong. Hold on. Sorry, bear with me. What did I do? Question mark? No. Is a number, oh yeah, right? Thank you. Still no dice. All right. Huh. All right. Sorry. Had a better example for this, and I got in the weeds. So anyways, this conditional binding thing, essentially the way it works is it allows me to execute some code if the value exists. Now see, let me set this to something. Nope, I got this wrong. Sorry. This is actually one of the cooler things, and I'm just blowing it. I think I've got an example down below that uses it. What's that? Oh, this guy. Pfft. Who needs that? Ah, man, I had a really good example for that. So bear with me. So it's basically a syntax that allows you to check for the presence of value. If it's there, it's going to pass it into the block. If it's not there, it'll move to the else. And actually, I'm just going to pull up the syntax because that's super useful, and we're going to need it. That is in the basics.
Online documentation is very helpful.
Yeah. Sorry, here it is. Right, right, right. If let. Oh, I know what I did. I'm getting ahead of myself actually. If let number. Yeah. And the optional in this case would be x, right? And it won't be, so I shouldn't have done that. Hey. All right, sorry about that. Brain reset. So what's going on here is x we set to the result of isAnumber.toInt, which is an optional. It does return a value, right? It doesn't return nil, which means that we drop into the block here. This is called optional binding, and it gets used a lot in Swift code instead of doing the not equal to nil magic. So while we're on the topic of types, I think we've gone through most of them. I'm going to talk about operators a bit. So most of the standard operators that you'd expect to see are there. All of your arithmetic operators, your assignment operator, your equality comparisons, they all work pretty much exactly the way you'd expect them to. There is one that you might not be familiar with depending on which language you're coming from, which is triple equals. Triple equals for reference types compares them that they are pointing to the same object, right? Not that they are equivalent. So equals equals says, is this thing equal to this thing based on the rules of that type of object? So if it's a string, are the contents of the string the same, right? Versus the triple equals thing is this the same exact string in memory? So that's the distinction between those two. Typically want to use equals equals. It's very, very rare that you're checking to make sure that the object's the exact same object. And then there's one more, which is this double question mark guy. So we have, in this case, we've got an optional up here. So I can say let coalesce equal to x question mark 0. So what's going on here, and I'll switch what x is pointing to in a moment. What this says is, if x has a value, give me x. If x is nil, give me 0. And that's the idea here. So if I change this guy up here to not a number, you'll see two things happen. One, if you're paying attention at home, is that the print line's gone, because that's now nil. So we would drop into the else case here. But also the coalesce number has been set to 0. So this is the nil coalescing operator. It's pretty useful for just defaulting a value. So say you're building a user interface where the user can specify the background color for some object. And if they do, you want to use that. And if they don't, you want to use green, right? So you would do user specified color equals equals, or question mark, green, right? And you'd get green if they hadn't specified something, and you'd get whatever funky fuchsia color they put together for themselves if they have specified that. So that's one more operator that you might not have seen in another language before. Another thing is you've got ranges. So ranges, they've got two types of them. They've got the type that includes the first and the last number, and that's a, what is that, open? And then they've got a half closed range, which is the first number all the way up to the one right before the last number. So these look like 0.10. It's funny, it returns it as the other one. So right, 0.10 gives me 0 all the way up to and including 10, which is equivalent to 0 dot dot less than 11, which is the other type of range. So I got 2 for the price of 1 here. That's how you would specify the other guy. So this is useful when you're doing loops, when you're running code a certain amount of times or something like that, which is a loop. So that's that. Strings we talked about a bit. But we didn't talk about something else, which is characters. So there's a character type. So I can say pi equal to pi as a character, so to be distinguished from a string. And that's interesting because if I didn't specify that that was character in this case, it would be a string by default. The type inference is going to favor anything in double quotes to come down as a string. But if I put a single character inside of those same quotes, I get a character instead. And you can actually loop through. A string. So if we do this, and I guess we can start talking about control flow. So there's a standard for loop, and then there's a for in loop. So your standard for int I equals 0, I less than whatever count, I plus plus, right? That style of loop is there. Boring, but it's there. But then there's also a for in loop. So I can do for in my name, right? And this is going to loop over each one, and I could print them out. And you see them up here. Never mind that UPC line, that's for later. But the characters of my name got printed out one at a time. So that for in loop is saying, give me each character in the my name string iteratively going through. So that's that. Let's see. So there's also while loops, standard while loops. I don't think I need to write a while loop. You know what that is? Like while some condition exists, run this code. Once the condition is done, exit that. And there's also do while loop. So guaranteed one iteration, check the condition, and then loop through until the condition is false. Pretty standard stuff there. Oh, strings. My goodness, something super valuable. So I can do something called string interpolation. So instead of doing these format string kind of things where I say, here's a string with a bunch of placeholders, and then here's a list of values at the end of it, plug those values into the string, Swift has something called string interpolation. So we've got a bunch of things that we've used up here over time. So we've got this is a number thing. Let interp string. I'm trying to name these so that they won't collide, right? That's why they're weird names. So I could say our is a number value, and then the way this looks is inside of the string we've got this slash and then parentheses, and inside the parentheses goes what I want to interpolate into the string. And in this case, I was going to do is a number. So as you can see in the results panel, it has substituted the value of the is a number variable into the string at the place where that interpolation operator is. Does that make sense? So you can build out strings plugging in values that you've seen from other contexts. So that's string interpolation. I don't know if you noticed it, but Unicode works. So here, where I said pi, I can also do this, right? That's valid. So that's a variable name right now that corresponds to pi. Yes? I'm sorry, what? Is string mutable or immutable? Have you worked with Objective-C before? All right. No, that's a common question for people that are coming from Objective-C. String mutability and immutability depends on whether it's set as a constant or a variable, right? So they removed the context. So Objective-C has a mutable string and an immutable string in the language. They decided to remove that feature when they built Swift. So now it's context dependent. So if I say let something equal some string, that string is now fixed. It cannot have things appended to the end of it and that sort of thing. But if it's a variable, it can be appended to, it can be manipulated, I can remove things out of the middle of the string and it won't make a string copy, it'll actually change that string directly. That's a good question. So this is kind of dumb here, but I could do that down below. So now, like this character pi that I can type with my Mac keyboard with Option P is actually valid, right? That's a valid name. This works for all kinds of crazy things. I'm not going to do the thing that Apple did in their keynote where they set something equal to dog cow. I will not do it, and that's an old time Apple joke. But emoji works in your code. Do not. If I see emoji in your Swift code, please do not put in comments that says Brent said this was okay. I will find you. I will find you. I'm gonna search that on GitHub because now it's gonna happen, right? So yeah, this is cool. I guess. So Unicode works if that's your flavor. Emoji works if that's your flavor. I highly do not recommend that at all. You can index into strings. That's another thing that I guess I missed. So I can say, give me the start index, and I can see what's at the start index, that sort of thing. I can see the end and that sort of thing. There's a lot of methods on string. They all come from, well, they don't all come from. So the Swift string class implements some methods of its own, but it also supports every single method on another class called NSString, which comes from the Objective-C world. What's really interesting as we talk about that, and as I talk about some other types that I missed, which is my array of ints. So I didn't talk about arrays. I can initialize this way, right? Standard array, literal syntax. Array binds to Objective-C's NS array. Dictionaries bind to NS dictionary. String has some bindings on NS string. There's a lot of, if you're familiar with Objective-C, there's a lot of parallels between the objects that are available in Swift and the ones that were available in Objective-C. You can, for instance, pass a Swift string to anything that accepts an NS string. So that's helpful when you're working with old iOS or Mac code. If you need to pass new Swift objects into it, you can. I said that I was going to do explicit typing where it makes sense the first time you see something. So this is the full syntax for an array. I don't want to type that. Another thing is, what does the shorthand syntax look like on the right-hand side if I wanted to shorten this further? Well, this kind of looks like that instead in shorthand form. So there's a shorthand form for this, and there's a shorthand form for the next thing, which is dictionary. So my dictionary, actually I don't even need variables for these. I'll just define one here. So this is a dictionary of type string int. I will set it something. Okay, so that's a dictionary. Keys are strings, values are integers in this case. We can do type inspection again, option click. You'll see that. Here's the shorthand for that guy. So that looks like this if you couldn't see it. The long form is dictionary of string int. Again, it's a lot of unnecessary typing. Instead of that, it actually looks like this. And that's helpful. And this carries over to, say you wanted to empty this guy out. So with type inference, Swift knows, so if I wanted to declare this empty after the fact, just to clear it out, I can do this. Because Swift knows, maybe. It used to know. Oh, that was the thing I said, that the type safety was going to bite me eventually. Yeah, so that's an empty string int. Right? I could specify string and int inside on the right-hand side of the equal sign. I don't need to, because Swift knows that y is a dictionary of string keys and int values. Remember, I said the type safety is really strong. It's going to hold on to that till the end of time, but you get some nice things out of that, right? I don't need to type the key value types when I come back later. It knows. So that's dictionaries, that's arrays. There's also a set object. It's similar to arrays, except it's unordered, and you can only have one of a particular value inside of the set. Not too much different there. Let's see. What should we talk about next? Oh, enums. So I can have an enum. Let's say compass points. And we'll have different cases. So there's a couple different ways to do this. I can do this, right, where I'm just specifying each one on its own line, or you can have them all on the same line. Since this particular enum doesn't have anything special about the points, they're all just sort of different. So what I can do now, though, is I can have an object or a variable reference this compass point. So this is my heading, and I'm going to say that it's a compass point. Why did I call that compass points? Compass point. And I'll set it to compass point dot north in this case. So heading at this point refers to something called compass point dot north. Later, when I want to update the direction that I'm heading, I can actually set heading equal to, let's say I'm going east now. I can actually say dot east in this case. Why? Type inference. So Swift knows that heading is of type compass point. So I don't need to type compass point dot east, compass point dot north. They give you shorthands where they can. If you haven't noticed that as sort of a theme with the language. This makes things like switch statements, which is my next control flow, a little easier to read. So if I switch on heading, and I do case, well, again, type inference, it's going to know that this is a compass point. I don't have to be verbose about compass point. I can say dot north. And then I can put some code in here for what it should do. In that case, heading north, boring. So it's not. So I'm getting an error. So in some languages, you can create a switch case statement that's non-exhaustive, right? It doesn't have to cover every value that's possible. Swift does not allow you to do this. You have to cover every option that is possible for what you are switching on. Sometimes that's impractical. If you're switching on, say, a set of 100,000 integers, right? Probably not going to happen. So you can do a default. In this case, that's what I'll do. So we can do a default and say, not north, which is what's going to print out in this case. And it's valid now, right? So we've covered everything. Default will be a catch-all. The only one we've specifically stated in this case is north. And that's cool. So what's really neat with the switch case statement, and I think like later you should dig into, is seeing how deep this thing runs. So let's say I was switching on something like actually I showed below. So let's talk about another enum. So I've got this barcode enum that you've seen this result over in the output panel for. I've got this barcode, two types. I've got the UPC-A, which takes a number system, a manufacturer, a product, and a check digit. And then I've got a QR code. I'm doing great. It's great. Thanks. Stop. I love her, by the way. It's great. So I've got a barcode enum. And then I've got the two types. So I've got the standard UPC that you've seen before and QR codes. QR code is just a big string, right? It's a jumbled up string. And then the UPC's got these different subsets. And I can create a new barcode by saying barcode.upca, passing in the values for those different integers. So if you're catching on, right, the enum object in Swift is a little more powerful than it is in other languages, right? It can store values with it in addition to the type itself. So I can create things like a bunch of barcodes, right? I can still check that it's of type barcode.upca, but then I can also do something with the values that it packs along with it. This might be valuable when you're doing things like I was talking about before, making web requests, right? I want to return a whole bunch of different things in a response. Maybe the status code that comes back from that actually has a 404 and a description and maybe some extended details of what happened, packaged up in an enum instead of like an unnamed tuple. This is pretty flexible. What I'm actually doing with it down below is switching on the product barcode, and if it's a UPCA, I have a bunch of lets, right? This is similar to that optional binding we did before. This is saying if this product code is a barcode.upca, let me have the number system, manufacturer, product, and check inside of the case scope. Similarly, if it's a QR code, let me have the product code as a string that came off of that. And then I'm just printing that out and do it with the QR code. But I can do that in here. Put the product code in string interpolation. I believe I typed something up above. Nope, we're good. So if that were a QR code, then it would actually output the string that's inside of the QR code as well. Does that make sense? The enum object itself is implemented as a struct. It can be extended. I'm not going to get into like the more advanced bits of Swift because we just don't have time. But you can extend enums to give them methods, right? The enum struct can actually contain methods and that sort of thing. Super interesting. Since we are getting low, I'm just going to keep powering through. But classes, so I could create a class, dog, I don't know. And I could say that it has a name. That's a string. What's that, Defido? Why not, right? So that's a property. If you're coming from different languages, sometimes properties have super special syntax where you've got to do getters and setters. Sometimes there's a distinction between class level fields and properties. Sometimes there's automatic properties, but you have access to a backing field. In Swift, they just look like variables declared inside of the scope of the class. Does that make sense? Getting ahead of myself, we need functions, I guess. Functions are good in languages, is that true? That's what I've heard. We'll do say hello as a real simple function, just so that we can take a look at syntax. No parameters in this case, no return value, because it's just going to say hello. That's not very personal, right? It would be better if I could say hello to some person's name. That's a string. So that's what parameters look like inside of functions. And then in here, I can say hello to this person's name. And are we not getting there? Anyways, that's what a function would look like if it doesn't return anything. If it does return something, just for giggles, I suppose, we could return an integer out of here. And the way we specify return types, this arrow, and then the return type itself comes out of there. Now I can see what my error is. Expected type for function result. What's that? Returning an int here. Oh. What's that? Want to walk away. I'm just kidding. Anyways, does anybody have any questions on what we've covered to this point? Trying to recollect. What's that?
So that parameter or that thing you set up in the class,
Yeah.
you just call it a variable, right?
Yeah.
It's public.
Yeah.
So how do you?
Well, no, it's scoped to the instance. That's an instance. Yeah. It's an instance property, right? So that would be a property on a new dog. Like if I created a new dog object. Yeah, sorry. Sorry about that.
It's still public, right?
Yeah, so it's not like a private, yeah, it'd still be a public property, but it's scoped to that object.
You can't hide it.
No,
How do you hide it? You don't?
no.
So everything's wide open.
I actually don't know that, to be honest. I haven't played around with private stuff. I did want to show you one more thing before we run out of time here. So I've got this. I have this object here. Let me make sure. I think we've got probably errors above still. What's our problem here? Oh, you know what? I never imported. Never showed you how to import things. So if I wanted to work with UIKit, so let's say I wanted to work with some iOS objects. So this is an iOS playground. I can bring in UIKit to play around with things that are available on the iOS platform. And I can also bring in this helper thing for playgrounds. It's called playground. Yeah, and that's going to give me this thing that will allow code to continue running after it goes through. So what happens by default is the playground runs top to bottom every time something changes, and then it stops. That's not very helpful if you have asynchronous callbacks happening. Maybe you're making web requests, that sort of thing. So this will allow you to let execution continue indefinitely, where indefinitely is scoped by the value in this little box down in the bottom right corner, which is, in this case, 10 seconds. It's for small values of indefinitely. So what this code is doing is using something called Swift Request that somebody on my team wrote, which is a library for making HTTP requests. There's another one called Alamo Fire. But I'm getting an instance of the Swift Request object. I'm calling get out to this bit.ly URL. Something you'll want to take a look at after this session, because I didn't get to it, is closures. So closure syntax allows you to pass around function blocks. I can actually pull in some code I wrote earlier. We can take a look at what the closure syntax looks like. But functions are implemented as closures, so they're very similar. But what this allows me to do is specify a callback. So go out and get this bit.ly URL. When it comes back, run the code inside of here. What it's going to pass in is an error, a response, and a body when it comes back. I check to see if the error doesn't have a value. If it doesn't, it's a valid response. And then I am doing a cast here. So this is not super safe. I could use the optional binding that we did earlier, the if let something equals something, and then put code inside the block. This as exclamation point says just cast it. I trust that it's there. In this case, I do, because there was not an error. So I'm grabbing the body of the HTTP response, casting it as this NSData object, which is how UIKit represents data as a blob. And then I'm creating a new UI image object out of the resulting data from the response. Now, that might be funky, because you just saw Swift, but I trust that all of you will shake it off. It's a Swift session. You didn't expect there not to be a Swift reference, did you? All right, sorry. I apologize. This has been a Swift introduction to Swift. I am sorry that we got cramped on time. But if anybody has any questions, feel free to come see me. I'm going to throw some more code up there in the meantime. But thank you guys for coming.